Hi, this is Andrea Hendricks. The topic of this video lesson is on rational functions and asymptotes, and we are going to begin with a review from college algebra and then talk about how to find the domain of a rational function, find the vertical and horizontal asymptotes of graphs of rational functions, describe the behavior near these asymptotes, find where holes in graphs of rational functions occur, and use rational functions to model and solve real-life problems. So let me begin by talking about topics that you should be familiar with from college algebra. If you recall, two of the basic functions that you learned in college algebra are f of x equals 1 over x and 1 over x squared. What you did in college algebra with these was you graphed them and then you shifted or reflected or stretched. So you use the basic transformations to obtain other graphs of rational functions. So let me remind you of the shape of those. So the graph of 1 over x is going to look like this first picture that I have here from the graphing calculator. The things that you want to pay particular attention to is that there are some asymptotes. There's something that we call a vertical asymptote, which occurs at the line x equals 0. And there's also a horizontal asymptote, and that occurs at the line y equals 0. Okay, so in fact our domain of this basic 1 over x was negative infinity to 0 union 0 to infinity. That is, the graph extends to the left of 0 and to the right of 0 indefinitely, but does not cross the vertical line x equals 0. Our range is basically the same thing, except we're talking about y values, so reading from bottom to up, it goes from negative infinity to 0 union 0 to infinity. So again, we had a vertical asymptote at x equals 0 and a horizontal asymptote at y is equal to 0. Now the graph of 1 over x squared also had vertical and horizontal asymptotes. Our vertical asymptote was again at x equals 0, and our horizontal asymptote was at y equals 0. So we had a domain very similar to the first function, that is from negative infinity to 0 union 0 to infinity. Now our range is different because we don't have any part of the graph extending below the x-axis, it's just above, so it is from 0 to infinity. Again, stating the vertical asymptote was x equals 0 and our horizontal asymptote is y equals 0. So let me remind you of how these relate to the graph. Do you notice in the original function the denominator takes on the value of 0 when x is 0? Well, that makes the whole expression undefined, so we have to exclude that number from the domain. So where the denominator is equal to 0 gets excluded from the domain. The other thing I want to mention to you here is how the graph looks near these asymptotes. So just to remind you, as we go to 0 from the left and right, notice that the graph is going off to positive or negative infinity. So we would say as x is going to 0, y is going off to positive or negative infinity. But what happens as we get larger and larger and larger? Right, as we divide 1 by larger and larger numbers like 1/10th, 1/20th, 1/30th, 1/100th, notice that we're getting smaller and smaller and smaller. That is, we're getting close and close to 0. So we say that as x goes to plus or minus infinity, y is approaching that horizontal asymptote of 0. And I'll review these things in particular with you in another video. But likewise, we can say that similar thing over here. As x is going to 0, that is, as we're getting close and close to 0, our y values are going up to infinity. So y is approaching infinity. But what happens as we get larger and larger and larger, that is, as we go out left and right, our y values are getting smaller. So we say as x goes to infinity, y is approaching 0. Okay? So let me stop this video and we'll start another one on the next objective. But just to review the things that you should know, so if you have trouble with this, you may want to go back and look at my videos that I did on these topics in college algebra.